The addition of tie finding to a Harsco Track Technologies production tamper is just the first step in what is envisioned to be the most revolutionary technology advancement in maintenance away in years. Here's a look at the technology at work. The goals of tie finder tamping are multifaceted. Among them are to not only provide an automatically indexing machine, thereby relieving some of the ergonomic stress on the operator, but more importantly, to allow the machine to work more quickly and more consistently than the operator likely has the ability or stamina to do. The first step in achieving an automatic indexing machine is to find the target. In the case of the tie finder, we're looking for ties, but more specifically for tie plates. The bell-shaped carrier near the front of the machine contains the probes used to detect the ties. Notice how consistent their position is held in relation to the rail. An encoder wheel keeps track of the machine's position, calculates the machine's speed, and triggers the tie finding probes to collect the data that will be used to determine tie location. The data collection and computation for this part of the process takes place entirely in the Jupiter modules themselves, and as the location of each tie is determined, a small amount of data on tie locations is sent to the master computer. Farming out an extensive part of the logic required for tie finding is a capability unique to the Jupiter system. The information on tie locations is then maintained in the master computer until needed. Here the logic is applied that correlates the current machine position with the location of a tie originally found some 20 feet ahead of the workheads. As the next found tie approaches, the master computer combines information on the machine's speed and position and compares this against the next targeted tie location and the projected distance needed to stop the machine in order to successfully center the launched workheads around the tie. The operator interface for the tie finding option is built neatly into the standard screens for a machine. Should the operator need to reference it, the basic information about system settings are displayed on the main screen. This information includes the current tie tamping pattern selected, the distance of next tie to be tamped, and the set working speed for tie find tamping. Since the tie locations are found at the front of the machine must either be driven forward or worked manually by the operator up to the position of the first tie. If the operator works the first few ties manually as he approaches the first found tie, the software that controls the indexing of the machine literally learns how to best control the machine, which can vary based on the track grade and rail conditions. Push of a button on the touch screen is all that is required for the machine to start working in automatic. The operator can adjust the average working speed as appropriate for conditions. You'll notice from this view inside the cab that the operator is not using the joystick to control the index and cycle. Now, notice the operator flipping the manual squeeze switch. While in the tie finding mode, the standard manual squeeze switch becomes a safety switch, requiring the operator to cycle its state from closed to open or from open to closed once every 30 to 60 seconds, depending on the tamping pattern being used. The operator at this point might be inspecting surfacing results on the screen, turning around to observe the results visually, or maybe grabbing a snack from his lunch pail. Meanwhile, the machine's not interested in what he's doing. The machine's just happily doing its job, which is to tamp track, without requiring the operator to be in his seat, hunched over, with his hand on the index lever all day long. Once the machine is successfully started in tie find mode, it continues to learn with every index and cycle. As the grade changes, stopping distance for the machine changes as well. TIE Finder software records these often nearly imperceptible changes and then refines its future control behavior based on this new data, interpolating how best to stop the machine from any likely indexing speed. Should the operator fail to cycle the safety switch within the required time frame, the machine stops where it is and waits for user input before allowing traction or work to resume. Model 6700J production tampers not equipped with the TIE Finder are operated in either the manual mode or auto mode during production tamping operations. In the manual mode, the workheads are raised and lowered by operating the workhead lever or optional foot pedal. Activating the lever again provides a second or third insertion as needed. Since this method involves more operator interface, production rates are not as high as when using the TIE Finder. This mode is frequently used when more than 3 insertions are required and in switch tamping operations. When working in the auto mode, the operator releases the hand lever or foot pedal, allowing hydrostatic braking to stop the unit with the tamping blades straddling the tie to be tamped. In this auto mode, the workhead will automatically start tamping the preset number of insertions when the rail is clamped. Some operators have the habit of dropping the tamping tools into the ballast before the hydrostatic braking fully stops the machine. Over time, this increases unnecessary wear and tear on the guide rods and guide rod bearings. This is better seen when shown in slow motion. In TIE Finder mode, the machine operates more consistently, and tests have shown that the TIE Finder option will outperform the best operator with less wear and tear on the machine.